Okay, in this lecture we're going to talk about two of the most predominant paradigms or theories that are used in test situations. Now these are referred to as test theories, but you can think more broadly in the same way as I've been using the language throughout the other videos as these being observation theories. So these are theories about the nature of the observations that we make. So the first is known as classical test theory. And in classical test theory we have a very simple set of assumptions. We have some kind of true score or true observation that we are interested in. And when we try to make an observation, we can never quite get at this true score itself. We always have some degree of error, some random amount of error that's introduced into the process that leads to the observed score that we actually make. Now, within classical test theory, depending upon how you kind of approach it in terms of your philosophical assumptions, more often than not, though, it aligns with more of a kind of operationalist, kind of positivist, strong operationalist type approach. You notice here that the empirical observations we make, the observed score, exist within what the critical realists would call that empirical world. But the true score is the underlying kind of unobservable latent variable that we're interested in here, but it is specific to the operation that's being performed. There is no crossover with other operations. There is only the value or the observation that the inherent value of whatever operation, whatever test, whatever kind of observational process we are using in that situation. It's not transferable in that sense. Now, within classical test theory is where we primarily get a lot of our conceptualization of reliability because of this error factor that's included into it. It is the fact that we have some error that means we do not get perfect indications or perfect empirical reflections of this underlying true observation or true score, and this is where we give rise to the concept of reliability. And classical test theory has a number of approaches, and over the years statisticians have developed a number of methods for determining the reliability of a given operational process or test that we use, independently of whether or not the data is of categorical or nominal scale, so it is data about qualities or individual entities or objects that we're interested in, or whether it is ordinal scale data or interval or ratio scale data. There exist reliability statistics that can be calculated capitalizing on classical test theory that allow us to understand the reliability of the observations that we're making on any of those kinds of scales. So this can be applied to qualitative and quantitative observations. Now, as I say, classical test theory fits nicely within a kind of operationalist perspective on things. The fact that the test itself is the thing we're interested in, not necessarily the test as indicative of some underlying theoretical concept or construct of interest that might exist within a broader nomological network. However, the current most dominant paradigm within test theory, at least within educational testing and psychometric testing and other areas of kind of psychology where we typically deal with unobservable concepts or constructs of interest, is what's known as item response or latent variable theory. Now, don't be too put off by the mathematics here. You don't need to fully understand them, and it's a huge world of complicated models. But in essence, the way item response theory is conceptualized is that there is some relation between the individual that's performing a test and the item within that test or the task that they perform. The reason we use the term item is because this theory comes predominantly from a background in psychometric or educational testing, where you might have, for example, an exam or a test that has multiple questions or items within it. But you can think of this as essentially being the characteristic of the individual and a characteristic of the operation or the test that you're performing. And so the characteristic of the individual is often referred to as something like an ability parameter. And then each of the test operations that you perform or the items that you perform may have one or more other parameters associated with it. And it is the interaction between the individual's underlying latent characteristic, whatever ability or concept it is we're interested in, and the underlying latent unobservable abilities and characteristics and concepts related to the test operation itself that give rise to the observed data that we see. So, for example, in this case, we have something called a 4-parameter logistic model. Again, you don't need to understand the maths itself, but essentially what we have is a plot there that demonstrates visually how something like a test operation that would fit a 4-parameter logistic model would look. On the x-axis, we have degrees of the underlying latent ability characteristic from the individual that we're interested in. And as the ability level goes up, the probability on the y-axis that they will successfully complete the test operational task, or they may endorse a particular item in a questionnaire, increases as the levels of their latent underlying parameter goes up. Now, in this 4-parameter model, we have a couple of characteristics relating to the items. We have what's known as a difficulty parameter. We have a discrimination parameter, such that certain items might be better at differentiating between higher or lower ability levels. And we can also have things like a guessing parameter or a lapse parameter, particularly if, for example, this was an exam with multiple choice questions. You could get one right just by guessing, so we can factor that probability in. And we can also factor in the fact that you might know the answer, but for whatever reason got it wrong that time. Maybe you had a lapse in memory, or you were distracted. Item response theory is not widely used in sport, exercise, therapy, and these sorts of areas. It's more used in psychology, psychometrics, education at the moment. But we are looking at applications of item response theory in these areas. So, for example, we're currently working with looking at using item response models to measure sports abilities. So, for example, in soccer, we can look at whether or not someone successfully makes a pass or not as potentially being a result of their underlying passing ability. You can think of this almost like a character in a role-playing game. That character may have a series of characteristics and different amounts of those characteristics. They might have strength or dexterity or speed or charisma or something like this. And when they go to do something in the game, the amount of whatever characteristic it is that's responsible for allowing them to do that action will determine the degree to which they have, the probability that they'll be successful in performing that item, or how well they perform that item. You can think of this in something like sport as well. So, for example, a football player might have a more or less ability in passing. That will mean they are more or less likely to succeed in making certain kinds of passes. And so we're looking to apply this kind of latent variable theory to devise approaches to measure sports ability independent of just the test operations themselves. So it's important to think about the different kinds of test theories that exist. Classical test theory is probably more commonly applied, particularly in areas such as physiology and biomechanics, where the operations themselves are so close to the concepts that we're interested in anyway. We don't necessarily need to utilize kind of latent variables and things like that. But in other areas where we may not be able to directly observe the underlying characteristic or concept of interest within our theories, we can start to model them potentially using these kinds of theories.